Hi, I'm Abhishek Jha and I present our work Barlow Constraint Optimization for Visual Question Answering. This work is in collaboration with Badri Patro, Luc Van Gool and Tine Tutelars. Visual Question Answering or VQA is a multimodal vision and language problem where the task is to predict an answer given an image and a natural language question. Typical VQA systems learn a joint projection between question space and image space. The joint space is then classified into a fixed set of answer classes. Such a classification system doesn't account for the semantic similarity between any two answer classes and treat them as orthogonal bases of the categorical space. In this work, we aim to introduce an answer stream in this image and question joint space to enrich them with answer semantics. Furthermore, we want to reduce the redundancy of this image and question joint space. Since redundancy in the feature space reduces its effective capacity, we introduce orthogonality constraints between the latent feature dimensions to reduce their redundancy. Hence, in this work, we want to incorporate the answer alignment and the redundancy minimization as the two constraints to improve the feature space for the VQA task. We have four major contributions. We propose an optimization constraint using Barlow redundancy minimization hypothesis as a regularizer to the VQA formulation. We introduce an answer stream to the standard VQA architecture to align image and question space with the answer semantics. Since the naive addition of the redundancy minimization constraint is non-trivial and leads to an inferior performance, we introduce two loss balancing policies. The first one being align then Barlow and the second one being constraint optimization with Barlow. Finally, we showed that the resulting feature space of our proposed model is more interpretable than the base model it regularizes. Our proposed model regularizes the joint embedding of image and questions, and therefore it can be applied to any VQA model that learns such a joint embedding space. We apply orthogonality constraint on the autocorrelation matrix of the joint embedding features. We also add an answer stream and apply similar orthogonality constraints on the resulting autocorrelation and the cross-correlation matrices. The overall Barlow loss becomes the sum of these individual orthogonal losses. Finally, we perform a dynamic weight balancing between the cross entropy loss and the total Barlow loss. During evaluation, we only use the trained standard VQA pipeline to perform answer prediction. We compare our model with recent state-of-the-art methods and we outperform them on VQA CP-V2 and VQA V2 datasets. Here we show top 5 answers based on the softmax scores of the classification layer. We see that our proposed model assigns higher probabilities to correct answer when compared with the base model it regularizes. The resulting joint feature space learned by the COB model shows higher interpretability than the base model as shown by higher GradCam activations over the salient regions. To show the generalizability of our model, we evaluate it on a different domain of medical question answering, that is VQA RAD dataset and the GQA dataset. Our model outperforms the base models in both of these domains. For more information on further experiments, ablations, and results, please visit our poster.